All right, we're going to look at logarithmic functions today. We want you to be able to express a logarithmic equation in exponential form, go the other way and change it from exponential to logarithm, evaluate logarithms, and then use those to solve with a calculator. Definition of a logarithm function is this. We've looked at exponential form right here. So you got some value equals a base number to an exponent. You can always change an exponential to a logarithm form like this. These two are equivalent. So just like we have a base of an exponent, we have a base number of a logarithm. That's that smaller number after the log symbol or the log function. This value x is the same as this value x, so whatever you're taking the log of is going to be the number by itself, and then whatever this equals is your exponent. So some examples here. We want to express this logarithm in exponential form. So what we do here is we take our base number, which is 2 here. That's going to be the base of the exponent. The exponent's always going to be the number on the other side. So 3 becomes our exponent equals 8. And if you do 2 to the third power on your calculator, you do get 8. So these two are equivalent to each other on this. The next one, log base 5 of 25 equals 2. Again, that is true. If you change that to exponential form, 5 is the base number, 2 becomes our exponent equals 25. And so you get the same, again, this is an equivalent thing. 5 squared is 25. You can see it works. You can also do these in the calculator just to check. And we'll talk about some ways to do that as we go through the video. If you hit math and go to the bottom here, there's this log function that's available just to show you like that last one works. Log base 5 of 25 does in fact equal 2. So you can see that that is a valid logarithm. What do these look like when you graph them? So we're going to graph out this function and see what it looks like. We're going to use the same thing we did in previous units to graph. Let's make a table here. So we're going to have our inputs and our outputs. Let's try some numbers here and see what we get. Okay, so I just picked some numbers for x. We're going to put those in for y. So how we do it, just as I just showed you here, we're going to input those numbers into our calculator to find it. You can use that same thing. So you hit math, and then at the bottom you got this log base. You can use that to do it. So if we do this first one, our base is 2 on here, and the number we're putting in for x first on our table is -1. And if you put that in there, the calculator doesn't like this one. One thing you're going to see is that you can't do logs of negatives, and we'll talk about why in a little bit. Let's try the next one. So we're going to do the same thing here. Log base 2 of 0. That one also does not work. You can't, besides doing logs of negatives, you also can't do logs of 0. The rest of these here should work. So let's do the remaining ones now. So we're going log base 2 here of 1, and this one equals 0. The next one. Log base 2 of 2, and this one should give us 1. So we got 1 here. Now, while we're doing these, some of your calculators may not have this function available. It is possible to still do these on your calculator if you don't have this function. For example, let's take this one that we were doing. So we entered it in the calculator just a little bit ago as we put a 2, we typed in a 2 here, and we typed in for this, the bigger number here, 1, what we were taking the log of, and we got 0. You can also do that on the calculator by using this trick and hit your log button on the front. I'll show you in a second, and do log of 1, and then divide it by log of the base number 2, and that should also give you 0. So you can divide it that way. Just to show you that way, this should give a 0. Log button's on the left there, log of 1. You got to close up the parentheses, divided by log of 2. This should also give us 0, just like we got before. So that's a way you can do it if you got an older calculator that doesn't have that. Let's finish these last two. If we do log base 2 of 3, you get 1.58. And the last one should give us 2 for this one, but just to show you, you got log base 2 of 4, and this should be 2 because 2 squared is 4. All right, so now we'll graph these points out. Our negative and 0 ones did not work. We got a point at 1, 0. We got a point at 2, 1. We got a point at 3, 1.58, maybe right about there. 4, 2 is a point. So these points you can see kind of look like this. This graph's kind of going this way and traveling like that. On this other side, we don't have any values over here because remember it's there's no values for negatives, and there's no value for 0, but we do have values that are these numbers between 0 and 1, and what you see when you graph it is that these will approach 0 but never quite touch that. So that's what the graph looks like here. And what this is this is a mirror of those functions we looked at with the exponentials. It's the inverse, so it's a reflection across this diagonal line here. Remember graphing out those exponentials, what they look like? Exponential graphs, growth graphs look like this. It's a mirror image of one of those exponential graphs. So whenever you're graphing a log, it's a inverse. It's the opposite. It undoes an exponential. Two very famous logs are common log, which is log base 10, and natural log, which is log base e. E, remember, that's our natural number. That's why this one's called the natural log. So let's start with common log base 10. You'll always see 10 written as the base. Because this one is, like its name, common, if you just see log with no base written like here, that means it's understood to be 10. So if you don't see a log, it's just known to be 10 because it is used a lot when working with scientific notation. Natural log, that's log base e. Whenever e is the base, this one gets its own notation as ln. Log of the natural number, that's what the L and the N stand for. So if you see ln, that's understood to be log base e when doing this. So you would see it written as this: natural log of x equals y. The exponential form of that would be then if we move the e that's kind of understood to be there, it would be e to this exponent y would equal x. So that would be the inverse or the exponential equation that goes along with that log one. These are on your calculator. They're on the left side. usually next to each other. There's log and common log and natural log right there. Most scientific calculators have those for sure. So in these ones, express the equation in exponential form. They want us to change from log form to exponential form. It's like we did earlier. This first one, that's our base. So that becomes our big number to our exponent equals what we're taking the log of. And 6 squared definitely equals 36. On the next one, if you see natural log, what you got to remember is e is the base. So this one would be e to the x would equal 12. On the next one, it's another natural log again, so you got to remember e's there. So this would be e to the third power equals 2x plus 1. I want you to try a couple here. So pause the video, see if you can change both of these to exponential form. All right, let's see how you did. You should have on this one had 5 cubed equals 125, which is true. And on the next one, that's a natural log one, so you got to remember e's there. It'd be e to the x equals 25 would be the exponential form there. All right, next problems. Now we're doing the opposite. They want us to take an exponential one and write it in log form. So for this one, the first one here, what your base is for your power right here, that's our base number on our log. Whatever the solution is here, that's what we're taking the log of, equals, and then the exponent is what's on the other side. So when you're doing this, you can kind of, it's like 7 squared equals 49, kind of like that. The next one, this one is going to be log, our base is e of 5 equals x. Whenever it's log base e, we could also write this as natural log 5 equals x. The next one, there is a negative there, but that's okay. That's what it could be equal to. So as long as this isn't a negative, we're okay. So we can write this one out. So this would be log base 2, because that's the base of our exponent, of 1 over 16 equals negative 4. And that's what we should get there. Your turn on this. Again, pause the video, see if you can write both of these out in log form. All right, let's see what you got. Should have had for this one, log base 3 of 81 equals 4. And for the next one, log base 5 of 1 over 125 equals negative 3. All right, evaluate the expression. So these ones want you to solve it out. A couple ways you can do this. One is you could change it into the exponential form and then think in your head what it would be. So let's imagine this is equal to some unknown number here. We don't know what it is. If I change this into exponential form, it would be 3 to what power equals 1. And then if you can come up with that answer in your head, you can do it. Well, there is always an exponent that gives you 1 as the answer. Anytime you take something to the 0 power, you get 1. So we would know that here then that x equals 0 would be the answer. The other way you can do that is like we did before. You can do it on the calculator. So if you do hit your math button, go to the log 1 here and type it in. Log base 3 of 1, we should also get 0. Again, if you don't have that on your calculator, how you type that in is use the common log of 1, what we're taking the log of, close the parentheses, divided by log of the base number, which is 3. That should also give us an answer of 0. The next one, you change it again. You could change it to exponential form. We don't know, again, what the answer is, so it'd be 7 to the x power equals 7 to the 10th power. This one's a little bit easier to see. In order for those two to be equal, if they got the same base number, the exponent would have to be the same, so x would be 10 there. On the next, well, one thing on this, if you got the same base here as number here, you can kind of think of that as also going to cancel out there. And so like if those cancel out, what's your solution end up being? 10. So that's kind of a way to think about that one when you're doing it. The next one, natural log of e equals 4. Remember, base number on this is e. So if we did the same thing we were doing on the other ones, this would be e to the x equals e to the 4th. So kind of like the last one here, we know x equals 4. What you're going to come to realize is natural log and e are also kind of opposite. So if you cancel these out, answer becomes 4. You can also check that on your calculator. If you do natural log of e, and e is always above the natural log number there, to the 4th power, this should come out to be 4. Yep. All right, your turn. Try this one out, see if you can evaluate here. All right, let's see what you got. If you changed it to exponent form and did it that way, it'd be 9 to what power equals 81. I think most of you know that that exponent would have to be 2 because 9 squared equals 81. If you did it on your calculator, you should get the same results. This one wants us to use definition of logs to again find the missing thing. On A, if we change this to exponential form, it'd be 2 to the x equals 16. So 2 to what power would equal 16? 2 squared is 4. 2 to the 3rd power, 2 times 2 times 2 would be 8. 2 to the 4th power, 2 times 2 times 2 would be 8, times another 2 would be 16. So it looks like the answer here is 4. If you were unsure on what that power is, again, this one could be typed into the calculator to figure that out too. The next one you cannot type in your calculator. So this is one you do need to change to exponential form. So the next one in exponential form would be 4 to the 3rd power equals x. Well, this we can definitely do on our calculator, or if you can do that in your head, 4 times 4 would be 16, times another 4 should be 64. You could also do 4 to the 3rd power here and get 64. So our answer here is 64. The next one, natural log of what equals 2. This is one you do, again, need to change to exponential form. Remember, your base number here is e if it's natural log. So this would change into e squared equals x. And so if you wanted it as an exact answer, it would be that x equals e squared, or if they wanted the approximate answer, you could go in your calculator and do that. Remember, e is right above the natural log button, so e squared is approximately equal to 7.389. So depending on what they want for an answer. All right, your turn again. See if you can try 2 of these out here. See if you can solve for both. All right, the first one, there wouldn't be anything wrong with just typing that one in because there's everything on the one side there. So if you did your calculator here, we should be able to do that one. Log base 3 of 81. Looks like the answer comes out to be 4. On the next one, you cannot type that one in, so you do need to change the exponential form on this one. It would be 5 squared equals x. If we square 5, we should get 25 for the answer. So those are the 2 solutions there. This one, they just want you to use calculator and then round your answer out to 4 decimal places. So this is just using calculator to solve. We've done a bunch of these already here, but just to go through again, go to that log base part. You can do it this way where you type in 5 and 55, and we get approximation here would be 2.48. What they want is out 4 decimal places. So it looks like 9 if we round there. The other way to do that again, if you don't have that type of calculator that can type it in like that, is this should be equal to log of 55 over log 5, and if you type that in, it should give you the same approximation of 2.4899. The next one, log base 3. If you're doing that one, you can type it in. I'll type this one in the other way. So if you did log of 10 divided by log of 3, the base number, this should give us the same thing as what you'd get if you typed it in the other way. So looks like about 2.0959. Natural log, this one, you don't have to go through that math menu. Natural log's right on your front screen. So just hit natural log of 40. And you should get the solution there, 3.6889. So there's that one. Your turn, try on your calculator, see if you can type that one in, see what you get. All right, let's see if you type this one in, log base 2 of 110. Answer comes out to be about 6.7814. So there we go. All right, so that's kind of an introduction to logs, being able to go back and forth, use your calculator to solve them out.